Okay, here's another one for us. So again, it has the same form. So we've got a squared plus u squared, or x squared here. So it's going to be inverse tangent again. And so, but this is a definite integral. So we're going to, again, a is 1. And then this is, there's no coefficient here, so we don't have to worry about u substitution. It's going to be pretty straightforward. So this is going to be 1, right? So it's going to be 1 over 1, so it's going to be 1. So this is just going to be tangent inverse of x over 1, which is just 1, or x rather. So it's just going to be tangent inverse of x, and it's going to be evaluated from square root of 3 over 3 to the square root of 3. Okay, and so let's write this out. So this is going to be tangent inverse of the square root of 3 minus tangent inverse of the square root of 3 over 3. And again, this is where the unit circle comes in. And again, this is stuff that I'm assuming and that you already know what they are. Okay, so again, what angle has a tangent that's equal to the square root of 3, or the square root of 3 over 1, if you want to look at it that way. Okay, and again, remember the right triangle, right? Okay, so with tangent is what? Opposite over adjacent. So opposite over adjacent. And so what angle gives us a ratio of square root of 3 over 3? So again, remember, for a what? We've got, if it's a 30, 60, 90 triangle, right, you only got so many triangles to work with. So you've got what? 1, the square root of 2, oops, sorry, square root of 3, and 2. Well, it can't be 30 because that gives us 1 over the square root of 3. Well, it has to be 60. So it's going to be pi over 3 again. Okay? I hope that makes sense. Again, this is stuff that I'm reviewing a little bit just so you guys can get like your mind right. And then what about the square root of 3 over 3? Well, one thing you have to recognize here, and again, this just takes practice, is, again, why is the square root of 3 up here? We have a 3. Where in the world did that 3 come from? Well, remember that we don't want to have square roots down here. So one of the things, and again, let's go back to this, is for the 30, 60, 90 triangle, we've got 1, square root of 3, and 2. Well, if we're dealing with 30, it's opposite over opposite over adjacent, which would be 1 over the square root of 3, but we don't want the square root of 3 here. We're going to rationalize the top and the bottom. So if we multiply the top and the bottom by the square root of 3, we get the square root of 3 over 3. And so that tells us we're dealing with a 60-degree angle and a 30-degree angle. So this is going to be what? This is going to be pi pi over, pi over 3 minus pi over 6. And so if we change this to common denominator, we get pi over 6. Okay? So again, I went into a little bit more detail than what the textbook does, but again, it's because I want you guys to start dusting off. Again, I'm assuming you took Calc 1 last semester or maybe the semester before, so hopefully it hasn't been too long, but nonetheless, you gotta dust off the cobwebs. Okay, here's one for you guys. Okay, so this was for you. Now, before we end, this is the last problem for the section, and I realized that we did not do any problems involving secant inverse. That does not mean you don't have to be responsible for knowing how to do it. Okay, so make sure you practice, and if you have any questions about how to do the ones involving secant inverse, I'd be more than happy to help you. Okay, so again, email me, let me know if you have any problems. If you want to set up a Zoom meeting to go over some of the stuff, I'd be more than happy to do that. But that ends this section, and so with that, we'll start a new section on the next video. Take care.